Okay, so this is our final chapter, chapter 18. So I hope all of these videos on terms and definitions have been useful for you. I know there's a lot of them. So let's finish it up. So chapter 18, first term, I want you to know, is bioaccumulation. Bioaccumulation is just biology, bio, and accumulation, gathering stuff. Bioaccumulation is when biology concentrates things. So for example, if you think about plastics is a really good one. So if you have a tuna, a big tuna, swimming around in the ocean, eating lots of little things, little fish. For each little fish that tuna eats, that little fish probably has a little bit of plastic in it. Not a lot, but a little. And since the tuna eats so many little fish, and it may not get rid of all the plastics accumulate in the tuna. This is true of plastics. This is true of toxins. Bioaccumulation. Biodegradable is something that will eventually break down. So for example, oh, here's a good example. This notebook is made out of paper. If I take this notebook and I put it outside, in about a year, maybe 2 or 3, it'll be gone, right? The paper will break down, the rain being wet, the sun, animals, it'll just disappear, right? However, if I take this rubber ball and I put it right next to the notebook, this ball will be there thousands, tens of thousands, probably hundreds of thousands of years. This will not break down. This is not degradable. This is, and because it's made out of paper, plants, trees, bio, right? Biodegradable. Biomagnification. For this class, bioaccumulation and biomagnification are the same thing. It's a very subtle difference. And if you care about it, what it means is, I use plastics as an example. In a little fish, there might be 10 pieces of plastic. Each little fish. And a big tuna eats all those little fish. What it's doing is magnifying the plastics. The concentration is higher, right? So in the tuna, it's one fish, right? Might have 10,000 pieces of plastic because it ate so many little fish. That's biomagnification. Coral bleaching. You will know a lot about coral bleaching after watching the Chasing Coral documentary. In a quick definition, coral bleaching is when the coral kick out their zooxanthellae symbionts. They turn white, they bleach, because they have no color except for their zooxanthellae, and they pretty much die after that. So that's coral bleaching. It's a big problem, as you saw in the documentary. If you haven't watched it, please watch it. It'll be on the exam. Next term, dead zone. I talked about this a lot in class. Dead zones are areas where there is no life. It's dead. There's no oxygen in the water, which means there's nothing there, right? No fish, no crabs, no shrimp, no oysters, no nothing. A lot of dead zones are caused by what's called eutrophication. Eutrophication is just a very big fancy word for there's nitrogen and phosphorus in the water. That's pretty much what it is. When this happens, the little plants, the diatoms, dinoflagellates, remember all that stuff from a long time ago when we talked about primary productivity, grows a lot. So if you've ever been to a lake that one day was really pretty, or the ocean even, really pretty, and then you come back a couple days later and it's just covered in algae, it's got like slime, it's like, yeah, that's eutrophication. And it's not very pleasant. It smells really bad, it's not good for the environment, and also a lot of it's not natural as well. Greenhouse effect is the increase in global temperature of the earth by having more carbon dioxide in the atmosphere. So it's, if you've ever been in a greenhouse traps heat, and it's really hot and humid. I used to work in a greenhouse and it was very difficult, hot, difficult work because it insulates and traps the heat. Greenhouse gases are gases that act to trap that heat. And one of the big ones is carbon dioxide. We'll talk a lot about this in class. But there's also others as well. But carbon dioxide is a big one. Methane, CH4 is also a big one too. Next term is hypoxia. Hypoxia is just a fancy term to mean no oxygen. So when you say an area is hypoxic, there's no oxygen, which is generally a dead zone. Invasive species. Invasive species are species that invade new areas. So if you think about, like, I mean, the southern United States has a great example of fire ants. So fire ants are not native. They're not indigenous. They're not from this area. They were introduced, I think it was in Alabama, they were introduced, and they have spread, and there's fire ants everywhere, and it's an invasive species. Ionizing radiation. Ionizing radiation is, we talked about this a long time ago when we were talking about light in the electromagnetic spectrum. Ionizing radiation is a type. Essentially, it's a type of light that you can't see. So it's a radiation. Marine debris. Any trash in the ocean, right? So nets, plastic bottles, whatever. Marine debris. Marine pollution. Marine debris is a type of marine pollution, but marine pollution also includes chemicals, right? So you don't see chemicals in the water, right? It's not like you can't look at a jar of water and say, oh, there's the chemical, right? Can't. That's marine pollution includes chemicals. The next term is marine protected areas, MPAs. This is, I used to say it was new. It's not really new. It's been around for about 20, 30 years. Yeah, about 20, 30 years. And essentially what it is an area of the ocean or the coastline that is protected from fishing, from people going there. Generally, it's just fishing, right? And so marine protected areas are important areas, like, you know, where seals might go to give birth to their pups, right? So you want to protect that, and it's in the ocean. So that's a marine protected area. Mathematical model. I don't know why this is in here. It's a model using math to describe something. Nuclear energy is energy we get from using nuclear, like uranium or plutonium. Wow, closed captioning, got that right. Impressive. Nuclear energy is really common throughout the world. Varies where you are, but one of the problems with nuclear energy, we'll talk about this a little bit when we talk about not Fukushima. Was Fukushima? Yeah, in 2011, I don't want to say a full meltdown, but let's say nuclear disaster in Japan with it was a bizarre combination of a tsunami that resulted in a nuclear power plant having catastrophic leak. And there's some real drawbacks to nuclear energy. A real big positive for nuclear energy, it does not produce greenhouse gas. Persistent organic pollutants, POPs. Lots of examples of these things. The big one I want you to know about is called, it's another acronym, PCBs. PCBs. Well, I don't care, you know what it's called, but PCBs. They're persistent because they last forever. They never break down. And you can find them in polar bears. We'll talk about this in class, but they're a really bad pollutant. They never go away at all. And a pollutant is anything that pollutes. So, something that degrades. So for example, if you look at water, there's clean water, which is drinkable, and you could have polluted water. And you could have a variety of pollutants. You could have PCBs, you could have dirt. Dirt could be a pollutant. Feces, human waste is a pollutant. Plastic, lots of examples of pollutants. All righty, well, that is it for our terms for the entire semester. So hope you all enjoyed. And if you got any questions, you know the rules, just let me know.